Redevelopment on the eastern side of downtown Edmonton is beginning to take shape. Named the Quarters, this area will be transformed to accommodate up to 20,000 people over the next several decades. The upfront cost of infrastructure needed to handle this increased density has been taken on by the City of Edmonton under a community revitalization levy. The levy provides a mechanism to undertake improvements in order to attract investment into the area and for the city to recover its costs over the next 20 years through an increased tax base and revenues from within the area. City investments will focus first on the transformation of 96th Street from Jasper Avenue to 103rd Avenue. This area is referred to as the Armature, and it is the heart of this redevelopment project. We're here today with ISL Engineering and Land Services. They are responsible for preliminary and detailed design and construction services for the Phase 1 Streetscape project. Kevin Dieterman is the landscape architect, Russell Barth, the senior water resources engineer, and Angela Stewart, the water resources engineer. Russell Barth discusses the rationale for the project.
The city had decided for this development early in the planning stages to do what's called sewer separation, where we take the stormwater runoff and we put it into a new pipe system, a stormwater pipe system, and then we rehabilitate the old combined sewers in order to have them provide sanitary servicing for the new sanitary flows that would come from all the infill development. So what the city did was, first of all, is they implemented the beginning stages of that for the stage 1 of the Quarters development. And they put in a great big storm tunnel below the roadway, quite deep. And temporarily, it's currently draining at a slow rate into the existing combined system, but ultimately it's going to run all the way to the river. And so because stormwater urban runoff is a concern, any kind of redevelopments of this nature that provide sort of new stormwater flow contributions to the river need to be treated. We had not very much space to deal with, so we had to look at, it sort of directed us to look at the type of low impact development measures that can be located below sidewalks and below hard surfaces.
Actually, we looked at putting a pond at one point, a dual use dry pond area, but we figured out that wasn't going to work. But so
didn't have the land, enough land to make it work.
Yeah, exactly. So definitely, in these built-up areas, the structural soil cell system, sometimes is the only way you can go. There's just, you've got so many competing interests.
3 city blocks along the Armature will have silvacells where water will be directed. The soil volume is intended to have the capacity to absorb the 1 and 2 year 24-hour storm event. In addition, an underground cistern will provide irrigation for park space.
In order to prevent the grid from clogging up and causing problems with the structural soil cells, we still use the traditional street catch basins that are proven throughout ages to be very, very effective in terms of collecting grit. So from our case, we try to regrade the surface to slope down towards catch basins, and we collect the flows, and hopefully the grit, most of it settles out in the catch basins, and then we distribute these flows into the structural soil cells. And any excess flows will go through an underdrain system, because our ground natural soils here are clay, so they don't infiltrate very well. So any excess flows will be collected in underdrain systems, then again that get directed to the storm trunk sewer system that will eventually go to the river.
At the end of every block we have the standard catch basin infrastructure that goes right to the storm system. So there will be points in the year where the runoff is diverted from the LID system in the winter and shoulder seasons, but it's not going to affect the adjacent residences, developments, businesses, etc., and cause any sort of issues or a poor level of service or cause maintenance issues, because we have the standard end-of-block catch basins picking up and routing into the minor system. So the drainage pipe is buried there in that washed rock wrapped in filter fabric there. So the cross section of the road, it slopes from the property line there where the fence is, or the face of the building pretty much, and it slopes in down towards this curb line, which is kind of the edge of where that distribution or the drain pipe washed rock is. And then from the west side, the entire cross section slopes again to that curb line. So it's a swale section rather than the more typical crown section that traditional road may have. And so what that means is we're directing all of the runoff from the whole right-of-way to this one swale line, where it's picked up in the catch basins. You can see there the barrels are in place, just covered in plywood for now. Each one of those catch basins has a distribution lead coming out of it, and on the second barrel down you can see the teal pipe there. That's the distribution lead. That's a solid unperforated pipe. That connects to the distribution pipe, which is on the backside of the lamp pole bases. And so that distribution pipe runs longitudinally through the entire length of the soil cell volumes, and is releasing the stormwater up at the top of the soil profile, where it's infiltrating down through the soil. The soil mix is 3 parts topsoil, 3 parts sand, and 1 part peat, and that gives us the appropriate drain capacity, organic material required to both sustain the tree and plant growth, as well as deal with the stormwater infiltration.
One thing to note about the catch basins are that they're quite a bit shallower than would be typical, and that's just in order to have the catch basin lead tie into the distribution pipe at the top of the silva cells. So we use typical catch basin materials, but we just kind of shrunk everything up to make them shallower.
It became really quickly clear that it was essential that our infrastructure was designed to accommodate the existing maintenance equipment. We know that their trucks can pull up beside a catch basin, lift the lid, and put their vacuum hose into a standard diameter with a 500 deep sump and clean that out. As well, all of the distribution and subdrain pipes are a minimum of 8 inches in diameter, and that allows access for the camera and cleaning equipment, the hoses. We've also added clean-out locations. You can see that one piece of pipe with the white cap on coming out at a 45-degree angle. That's to allow the cameras and the spray equipment to go into the distribution pipe, should that ever become clogged, and access that with existing equipment. The system was designed kind of in collaboration with the operations folks based on their feedback, and then they reviewed and signed off on all of that. We've since had one of the operations fellows who actually does the work. He's reviewed the system constructed and said, yeah, this is more than enough. So this system may be over-designed. I'd be really curious to see, as this functions, whether it can be simplified to require less clean-out infrastructure, smaller diameter pipes, less cost. Because every time we put in a clean-out, we're taking away soil volume because it needs to be surrounded in washed rock, and we're adding a junction box at the surface, or an access box. So from an aesthetic perspective, it's lessened because we're needing to add a whole bunch of additional box cover lids on the paving surface, where we'd rather just have the continuation of the paving stone and the decorative paving surfaces. You can kind of here get a sense of the complexity of the soil cell layout in places. It kind of jogs around to get the soil in the right spots relative to where the tree planting goes. So no one element whether it's below grade the LID infrastructure or the surface infrastructure, paving patterns or curb lines, overrides anything else. Every element of the design is interconnected.
What we did to size for quality on this project was to try to see if we could come to the current City of Edmonton guideline. So just a handful of years ago, the city developed a guideline as sort of their first embarkation into this whole arena, and the goal obviously is to try to go for water quality events, which tend to be sort of smaller events, typical runoff events in each season, looking for sort of your cumulative over the course of a whole season, water quality benefits. The current design criteria in the guidelines that they've established is probably a little large, right? And you can kind of get that sense even by looking at the scale of our project here. I mean, we're 3 structural soil cells high by I don't know how many wide. It's quite a lot of soil volume. It's way more soil volume than the trees need. So one of the things that would be nice in the longer term is to try to learn from the project, do water quality sampling, and maybe rethink that guideline. And so we've got ourselves, we think, a Cadillac, or the city does, and we'll see how it works from here.
Yeah, that being said, the trees will never say no to more soil.
Right.
They're only going to do better. And there's still, from my perspective, not perfect clarity on how the trees will, and the soil volumes, will respond long-term to the loading, nutrient and heavy metal loads, how much is removed through the TSS versus how much is making it in, and then how distributed that load will be throughout the soil profile, and therefore how does that affect the trees. So I feel better about more soil, obviously, because the trees will have more opportunity to grow big and strong, and a better dilution, if that's the right term, of the contaminant load. So it is a Cadillac for sure. When you just look at it relative to other soil cell installations, we have tremendous volumes, more than the kind of minimum recommended volumes by most arborists for urban tree growth. So, anytime you can go better than the recommended minimums, you're giving it a better chance to thrive and be a true success. It's just really rewarding to have such a comprehensive undertaking and not kind of work in the traditional siloed approach. What we're doing is making an environmental improvement, and that's a commitment that the city's made on this project, that yes, is in fact worth the investment.
The Armature will be open to the public in the fall of 2015.
So we've had a lot of support, actually, internally from the different groups, the operations folks, the detail design engineers, and the planning engineers at the city, to support us to move forward with these ideas. So it's pretty darn exciting. There's always going to be some concerns, to work through.
It's pretty darn exciting, apparently.
There you go.